by the U.S. Department of Energy's Building Technologies Office. The report discusses how to assess actual performance of buildings that provide demand flexibility as they participate in programs and tariffs offered by utilities and wholesale electricity markets. Joining me today is lead author Steve Schiller. Steve is a senior advisor and affiliate with our Electricity Markets and Policy Department. He's an internationally recognized evaluation, measurement, and verification expert, and he's responsible for many of the guidelines and protocols used in the energy efficiency industry today. Let's go to slide 3, please. I'll first provide a little background on grid interactive efficient buildings and demand flexibility, and then Steve will cover what are assessments, why are they important. He'll give you the bottom line up front, and then he'll present fundamental considerations for assessments, their development needs, and how to plan for them. And finally, he'll highlight actions that state and local governments can take to advance demand flexibility assessments. I'll moderate discussion with the author following his presentation, and please enter your questions anytime in the Q&A box. Next slide, please. Our report is for the Sea Action Network. It provides resources for state and local decision makers on providing low-cost, reliable energy to their communities through energy efficiency. The report that we'll be discussing today is the third and final in the Sea Action series on grid interactive efficient buildings. All of the reports are posted on our Berkeley Lab website, as well as U.S. Department of Energy's website on grid interactive efficient buildings. The first report in the series is an introduction in the context of state and local government interests, their energy goals. The report outlines actions they can take to advance demand flexibility in support of their own energy-related goals. The second report of the series describes 7 ways to update current methods and practices for economic valuation of demand flexibility in electricity system planning and programs. And finally, the third report, the subject of this webinar, summarizes current practices and opportunities to encourage robust and cost-effective assessments of demand flexibility performance, and that can improve planning and implementation of programs and based on verified performance. I want to thank members of the Sea Action Network Executive Group who provided feedback on draft materials for these reports. Let's go to slide 6, please. So I just want to quickly put in context why demand flexibility from buildings is so important. For starters, the residential and commercial sectors represent 75% of electricity use in the United States, and in some regions, up to 80% of the peak demand. But because they have so many adjustable loads, buildings also represent a large source of demand flexibility. So they can be part of the solution to peak demand issues, and they can offer a broader range of grid services to help meet other electricity system requirements. Next slide, please. So what do we mean when we say grid interactive efficient building? It's an energy efficient building that uses smart technologies and distributed energy resources to provide demand flexibility. The building co-optimizes for 3 things. 1, energy cost. 2, grid services. And 3, occupant needs and preferences, and all in a continuous and integrated way. And when we say demand flexibility, we're talking about the capability of the distributed resources to adjust a building's load profile across different timescales. You can read more about these technologies at the link at the bottom of the slide, and the slides are posted on our website, so you can take a look at the links following the webinar. Next slide, please. Slide 8. We also refer to 5 demand-side strategies to manage building loads. First is energy efficiency, which is the ongoing reduction in energy use, while at the same time providing the same or maybe even improved level of building function. And then there are 4 strategies that we can harness to provide demand flexibility in buildings. Load shed is the ability to reduce electricity use for a short period of time, typically on short notice. So we're talking about, during peak demand periods and also during utility system emergencies. So for example, calling voluntarily for citizens to reduce energy use in California recently during the period of high peak demand. Load shift. that's the ability to change the timing of electricity use. And that may change the amount of electricity that's consumed. For example, shifting may result in using more electricity when it costs less, and reducing demand during peak periods when electricity costs are higher, particularly, if you can harness battery storage. Modulate is something that we expect to see more in the future, and that means balancing power supply and demand, or reactive power draw and supply autonomously. And by that we mean within seconds or even within sub-seconds in response to a signal from the utility or, say, a regional grid operator. For example, through modulation, a building could provide ancillary services like regulation reserves or frequency response. Finally, more and more customers are generating electricity from distributed resources like solar or gas-fired combined heat and power. And they can use that electricity, of course, for on-site consumption, but there are times where it could be particularly valuable to send that electricity to the grid, and the utility or a grid operator can send a signal, and the customer can make use of storage on site to be able to optimize when they deliver that electricity to the system. Next slide, please. So the point of grid interactive efficient buildings is that these strategies work in concert to improve the load curve that the electricity system needs to serve. So here's a stylized example. In the graph on the left shows that energy efficiency alone pushes down the load curve. And in the middle chart, if you add on-site generation like solar, overall use of energy from the grid is reduced, but the building's peak load on the grid may coincide with utility system peaks. The chart on the right shows that if we add load shedding and shifting, we can flatten the building load profile and provide the greatest potential support to the grid. Next slide, please. So our new report is focused on how you know what you actually achieve through demand flexibility in buildings. So first, we explain some basic concepts and considerations for assessing actual demand flexibility performance of buildings. And that's whether it's in the context of participating in demand flexibility programs or time-varying retail rates. We also provide information on designing assessments for demand flexibility, and we talk about challenges and opportunities as demand flexibility becomes more common and more sophisticated. We intend the report to be a resource for state and local governments, and also utilities, regional transmission operators and independent system operators, energy service providers, designers of building systems, building owners and operators, and also researchers that are developing and testing new assessment protocols. I really want to acknowledge our colleague, Sean Murphy, who helped with research for the report. And just as a reminder, please enter your questions at any time during the webinar using the Q&A box. Following Steve's presentation, I'll moderate discussion with him. Steve?
All right. Well, thank you, Lisa. Whoops. And thanks for the introduction, and also thanks for your support and guidance on this project as our principal investigator. And welcome, everybody. Great to see some familiar names, including many of you who make this kind of work possible. So I hope everyone's well in these strange times. So let's get started and talk about some real basics first. What are assessments and why are they important? So in the context of this work, assessments are about quantifying and documenting actual demand flexibility performance. They are retrospective in that they look at what did happen versus what might happen. And although they are retrospective, they can provide results very quickly, perhaps even in near real time. Some people think of such evaluations reporting taking maybe months or a year. It's sometimes the case for large efficiency programs, but that's not really the case with demand flexibility assessments. We'll talk about some more. For example, at my home, I participate in a demand response program. I get a request to reduce load for 1 or 2 hours, 2 days in advance, and then get my results if I met the target or not within a day or two of the demand reduction event. And it's all automatic. With respect to terminology, what I'm going to be talking about is called assessments to capture really a wide range of attributes, but most of us think of the term measurement and verification, or M&V, when covering this topic, and that's a common term for efficiency and demand response programs. Specifically, M&V is a term for dispatchable demand flexibility programs with their financial incentives. But for non-dispatchable utility tariffs, sometimes such as a time-varying retail rate, the term used is impact evaluation. And although this term can also be used for a wide range of assessments, we're trying to capture with the term assessments, M&V, impact evaluation, et cetera. And as the figure shows on this slide here, assessments are really fundamental to both the planning and implementation of all these demand flexibility activities. So why do we do this? So, let's get to the right slide here. You can assess me on how well I flip my slides. I think that'll be my big test today. So here's for why we do assessments, kind of a generic answer. They're threefold. One, document impacts. That's determine how well the goal's been met. For example, has there been a good use of the invested money and the time involved? And very importantly, assessments provide the proof of the effectiveness of the demand flexibility. Secondly, support resource planning by understanding the potential contribution of demand flexibility as compared to other resources. And then third, understand why the effects occurred. This is the feedback mechanism that's so important with all forms of evaluation. As noted in the slide here, the famous business expression of you can't manage what you don't measure, and things that are measured tend to improve. So one of the key takeaways from today's presentation will hopefully be that if you're going to implement demand flexibility, don't forget about the assessment process or the M&V or impact evaluation. Whatever you want to call them, don't forget about it. So in terms of why do we do this in terms of the context of actual demand flexibility, well, as will be discussed, performance assessments of demand flexibility involve determining the timing, the location, the quantity and quality of grid services provided. Such assessments are used, of course, for financial settlements, but as illustrated in this figure, they also have other important applications. I'll just mention a couple. They provide confirmation that buildings can reliably, cost-effectively, and consistently provide demand flexibility. This is really critical for the acceptance of demand flexibility as a grid resource. In addition, assessments can be used to optimize building performance, build confidence in the benefits. And the last one I'll mention, as indicated in the slide, is that for state and local governments, performance assessments provide data necessary to advance demand flexibility in support of their broader energy goals, such as reliability or renewables integration. So looking at the summary of findings, I'm trying to sort of get you going on just sort of under the strategy of tell you what I'm going to tell you. I guess in some ways I had this discussion with a colleague about a week ago about, and he was saying, we've been doing demand flexibility for 20 years. And I said, well, actually it's more like 40 years and probably goes back further if we talk about curtailable rate schedules. But in any event, for decades, we've been doing demand flexibility services. It's been a grid resource. And every day, these services are being provided via demand response or other things, and people are getting paid, and it's working. Thus, while we can and do find opportunities to improve performance assessments of demand-related services, to a large degree, current best practices, including the use of advanced M&V or M&V 2.0, are really sufficient for basic service offerings. However, advances in assessment practices will be required in the future as these grid integrated efficient buildings, as Lisa described, start providing more continuously, more demand flexibility using more DERs, doing more load shifting, more shedding, modulating, storing, generating, maybe even using EVs. And as this demand flexibility becomes more continuous and more sophisticated, we'll need to step up our assessment practices also. So I'll be talking about these as we continue, but a couple areas for upgrades are developing new baselines or counterfactual constructs, deploying more advanced metering and analytics, developing cybersecurity, further developing privacy and improving communications interoperability. And the last, if we're going to do more modulation, stepping up how we do modulation assessments. So I want to just sort of quickly run through, just to give you a feel of a typical day in the future of demand flexibility, give you a sense about where assessment practices might be. So in this scenario with lots of words here, let me just say, there's a building, it's participating in a aggregator's day ahead capacity market program. They receive a request on Tuesday morning to modify building operations for the next day. in a manner that provides a specific electricity load profile. The requested load profile would take the form of specified hourly consumption levels based on electrical grid capacity needs and the historic consumption performance of that building. Now it's Wednesday, and using the results of prior actions and machine learning software, the building operation systems use real-time meter data to control a generator, charge or discharge a battery, adjust the demand of the building's electricity systems like ventilation or cooling, and then at the same time maintaining the building's performance within predicted parameters for comfort and productivity. You know, during this demand event on this Wednesday, the building automation system also uses its energy management information systems and open ADR standards to communicate, you know, the performance data to the building operator and the aggregator. And then, you know, as well, you know, the overall information is provided. And then the next day, Thursday, the day following the event, the aggregator provides an electronic report to the building operator indicating whether the building performed as requested, whether the right load profile for each hour of the day, but also provides diagnostic information indicating how each DER contributed to the building's demand flexibility performance and recommendations for performance. This data also serves as a basis for any settlements, and this pattern is then repeated. So what we see is a future where there's much more integration, much more communication, and a lot more automation. So, you know, what would be the considerations for then doing this? So the next phase after we got through this basics. So in the report, we talk about 5 fundamental considerations to define an assessment. The big deal here is metrics. Metrics are numbers or other forms of information describing the process of interest. They indicate how a process is performing, and then metrics become a basis for making improvements to a process. But let me start actually at the top here. You know, first, objectives. What information is the assessment intended to provide, and how will that information be used? Bottom line, you can't know what you want if you don't know what you're going to use it for. The objective is obviously very important. Next up is the boundary. Relatively simple thing, but it's important for deciding, you know, are you looking at the whole building, or perhaps one individual building or system, or one DER, or one flexibility mode? And of course, you might also encompass, you know, many buildings in your boundary. And then, as I mentioned before, metrics are the big item, deciding what metrics will be assessed and how they'll be defined. This then defines what data will be acquired and what granularity, you know, subseconds to hours for the data measurement frequency. And so there'll be more on metrics I'll be talking about coming up here. Next, once you know your objectives and your boundary and your metrics, you decide the analysis methods that are going to be used. How you're going to be calculating your expectations for certainty. You know, will baselines be used? If so, how will they be defined? And then finally, you know, what are the actual implementation requirements, such as data collection, privacy, cybersecurity, reporting, timing of reporting, and then who's going to actually do this assessment? These all constitute what we do here. Now, you know, getting into a little more in this, starting with really, I just talk about the objectives here. You know, it's a starting point. And, you know, I'm not going to read through all these lines here, but let me just give you a couple examples. You know, let's say first for building owners and operators, you know, the objectives might be to, you know, stay within a certain level of demand during a billing period to avoid triggering demand ratchet. For state and local governments, your objectives might be about confirming whether programs or policies are actually working, have their goals been met, and having specific metrics tied to numerical targets. For utilities or grid operators or DER aggregators, you know, objective can be to determine the compensation for buildings participating in the programs. And of course, for electricity system planners, you know, including RTOs as well as state energy offices, can use the building performance data to inform forecasting and modeling, you know, for upgrades or, you know, the use of demand flexibility. And of course, there's even the designers of buildings that can use this information. So I was talking about metrics, saying that's really the critical one here. And so let me talk a little bit about those. As I mentioned, the real key to assessments is picking your metrics. And a reminder, you know, of what metrics are, it's in the little text box here. So in this report, we define 4 categories of metrics, and these are what I call the big one, which is the quantity and timing of demand flexibility provided. Some examples might be the amount of demand reduction during defined time periods in kilowatts or kilowatt hours, or really the change in kW or the kWh is the most common metric that we see for demand flexibility. Second category, quality of demand flexibility provided, such as how quickly the building responds or ramps up its change in demand or the persistence of the impacts. Then next one up is, I'm not going to go into too much, but we can discuss during the Q&A if people are interested, is around attribution of impacts, whether it's to the overall program or specific pieces of equipment, the DERs or the flexibility mode. What is it that got you the flexibility that you did receive? And then the fourth category is impacts on building owners and occupants, such as energy cost savings, or, was the health and comfort productivity maintained in the building? So going beyond those, some of these metrics of performance, let me, just mention that, for example, a state agency that we interviewed for this project, said that real information of interest to them was verifications of the participants' ability to take the demand flexibility action. Assessments can do that in that they indicate if a building has performed, that it's an indication of potential to perform in the future. Can they provide that grid services? Also, another area beyond just the actual performance ones and talking with system operators, they emphasize the importance of predictability of load. As one individual put it, grid operators don't serve savings, they serve load. Thus, grid operators need to understand whether loads participating in demand flexibility programs and time varying retail rates will meet the expected load profiles with respect to magnitude as well as the shape. These examples illustrate that the importance of demand flexibility information to both program implementers and others, determines the design of these programs and needs to be taken into consideration as you put together your assessments as well as your programs. So once we get past the, the objectives, the boundary and the metrics, you got to figure out how we're going to do this. What analysis methods are there going to be? So in the report, we talk about a couple different categories, actually two categories. Direct measurement methods are one, and well, they're basically involving direct measurement of a performance metric, thus not requiring a counterfactual or a baseline. For example, in real time, directly measuring energy output of a generator or the amount of charging or discharging of a storage system, or really even just confirming the simple shutting off of an electric water heater in response to a frequency support request. Next comes the trickier method though, and that's the baseline methods. Methods which require definition of a counterfactual. And there's two subcategories of that, measurement and verification, M&V, and control group methods. So we just as a quick reminder, the counterfactual scenarios are defined in a manner that represents historical load patterns. So what the load would have been at the subject building or buildings without the applied demand flexibility modes. Common example, building's power draw during a weekday event from 2 to 4 p.m. can be compared with a typical power draw measured for that building during recent non-event weekdays from 2 p.m. to 4 p.m. That would be your baseline. So M&V methods involve measuring, say, kWh for a building and comparing that to a counterfactual scenario. These are typically used for dispatchable demand response programs. Now, control group methods, on the other hand, involve comparing measurements of interest, again, kW, kWh, for multiple buildings participating in a program, or more likely a specific tariff. Those are the treatment group, and then comparing that with a similar group of non-participating buildings, the control group, during the same time period. Today, and probably in the future, control group methods are used for assessing collections of buildings participating in non-detachable tariffs. Oops. So I'm not going to go too much into this table here. It's in the report, but the basic point is that the application of the analysis methods does vary by demand flexibility mode and the services provided and the type of program or tariff. Again, this table is in the report. So before we leave analysis more, though, I just want to talk a little bit more about that baseline thing. You know, under current practices, any net changes in demand or energy use resulting from efficiency or load shed, load shift cannot be directly measured. For example, the true impacts of demand shedding are the difference between the building's electrical demand during an event and the demand the building would have otherwise required if the building operator did not participate in the load shedding program or was not served, say, by a load, time varying tariff. In practice, we can never directly observe how much demand the building would have used had not been in the program, because of any given time, a building must either be in the program or not. So as mentioned in summary earlier, today with how demand flexibility is practiced, in general, baseline approaches are working just fine. But in the future, reliably defining baselines can be more difficult as demand flexibility becomes more common. And in particular, demand flexibility events are so common, it becomes really hard to find non-event days or times to use as a baseline. Fortunately, there are some options now and in the future. And we'll talk a little bit about that quickly here, because I don't want to leave you too worried about that issue. For some demand flexibility modes and grid services, performance metrics may simply be based on direct measurements, such as the amount of electricity provided to the grid, from on-site generation. Another possibility, for the shed shift mechanisms, might be that we look at load shapes. The concept of load shape being that, is where the desired load shape, is met along with the magnitude of the demand flexibility event. There's also, that we might just end up moving more towards, the non-dispatchable price-driven regimes. And for those, baseline is determined not by the building, but by a control group, and we're not as concerned about individual building performance, just overall performance. And there, again, there might be some other options, that just don't rely on a baseline at all. Maybe, just comparing against a load factor, that is a peak to average load ratio over some extended period of time. So baselines may become more of an issue, but we're working on solutions for that if it does become an issue. So now it's time to actually implement this stuff. We're at our last of the 5 major considerations for putting together an assessment. And as the subtitle of the slide indicates, it involves more than just measuring stuff. This could be a whole webinar in itself, but for now, I'm just going to cover this by pointing out that the specific aspects of implementation and what has to be decided for planning assessments. This involves starting with what data and how it's going to be collected, next to what analysis methods, and then what analysis tools are required, and then aspects of using the results such as reporting and feedback loops. I'm not going to get into this too much because of time, but perhaps we can discuss in Q&A if people have some more questions, but another issue here is who's going to actually do these assessments. So before leaving this topic of the 5 basic considerations, this slide tries to sum up this assessment process by identifying 3 phases: the planning, the implementing, and the applying. Planning involves the 5 considerations as discussed, but let me actually talk a little bit about that 3rd phase. We don't want these reports to just sit on some proverbial shelf. Of course, they would be used for settlements, confirming contractual performance and payments and an incentive program, but they also should be used for feedback and planning, getting back to those objectives of this assessment process. If we know the information is going to be used beyond the assessments, then a structure needs to be set up that the right information gets to the right people in the right time so they can use it and take full advantage of this performance data that's coming out of this process. So with that, a little bit of background, let's talk about another area that the report gets into, which is, what are the development needs? So the fundamentals of assessing demand reductions from efficiency, load shed, generation, as I said, those have been in place for decades and are well established and can serve really as the basis for load shifting and modulation assessments as they're developed. Overall, things are sufficient for things in place today. But as I alluded to, in order to meet the full potential of these GEBs to integrate multiple DERs and flexibility modes, the assessment approaches will need to advance, to be modified or create new approaches And we can build on the existing practices, such as those that already exist within the M&V protocols, those that, for example, are found in the New England and PJM RTOs manuals, California ISOs, demand response guidance. Certainly existing advanced M&V practices help as well. And with all that, though, we may very well need to really upgrade these assessment practices. Moving forward, because it's pointed out in the second column of this slide, demand flexibility might get a lot more advanced itself, which is a good thing. For example, demand flexibility, might become more continuous or near continuous. Load modulation, might be more common, occurring within subseconds to seconds. And then increased use of combination of different DERs, and perhaps even including the use of EV charging. And all while trying to reduce the complexity for the consumers and the market participants, so it's as simple as possible. These create what I call the drivers, for assuming I can move this slide here, the drivers for development needs. So, with changes in demand flexibility on the horizon, what are some of these drivers? First, in the table here are changes that might relate to baselines with increased use of integrated shed and shift, buildings, providing multiple grid services, perhaps in overlapping programs. Let's say, for example, a building's participating in a retail program on Monday and then a wholesale program on Tuesday. Does Monday's load represent a proper baseline? And of course, increased number of events, as I keep alluding to, making it harder to just come up with a baseline. So development need number one, as we get more advanced, baselines. Next up, second category is just basics of assessment practices, how assessments are done. These challenges might be related to sorting out the contribution, the performance of individual building systems or piece of equipment or individual demand flexibility modes, versus today, which we generally just look at the overall building performance. Having the sub-information can become really critical for improving performance. And certainly, there's more data. We're going to see more data and the ability to manage that data quickly, and that's going to put more pressure on cybersecurity, privacy, and interoperability. And then the last area is modulation. Today it's a less used demand flexibility mode, but if we get more and more in that, we're going to see a need for defining, metrics specifically associated with that modulation mode. Here's another slide I'm not going to go too much into here, but again, this table is in the report. And what this table is just in a nutshell trying to show is that virtually all aspects of demand flexibility assessments, offer opportunities for improvement for determining the impacts. But the needs do vary. If I could summarize, it'd be either respect to efficiency and demand flexibility modes of generate and shed. Assessments again are in pretty good shape. Maybe a little less so for the shift mode, and certainly less so for modulation. But then when we start looking at multiple flexibility modes, dispatched frequently, that's when the development needs become more critical going forward. So let's talk about planning for the future then with this background. So a lot of things, like a lot of things in life, are about balancing, balancing the needs, the costs, the benefits. How good is going to be good enough in the fundamental, what I think of as the fundamental question of life, as compared to what, and so here's a summary list of some takeaways. When developing demand flexibility projects, don't forget about the assessment needs. That is, how are you going to assess results and judge success? Next, take into account the 5 considerations that we talked about here and in the report, assessment objectives, etc. And lastly, while today's practices can suffice for today's demand flexibility options, if we get to more sophisticated demand flexibility options, we're planning to utilize modulation or demand flexibility on a regular basis. New strategies, such as new baseline constructs and implementation support, are likely to be needed. So with that, what are some actions that states can take? States and local governments, this is a C action report. So we do want to focus on what are the opportunities for those participants. So state and local entities have multiple roles can be involved in demand flexibility, and thus in their assessments. As shown in the top row of this table, they can be regulators, they can be program operators, they can set codes and standards, and of course they have their own buildings to operate as well. And in each of these roles, they can always find ways to support assessment, from just encouraging them, that is lead by example in your own buildings and programs, to encouraging or even requiring the capabilities and systems to not only do demand flexibility, but also have the capability to assess them, including working on metering and interoperability, security and privacy infrastructures within your jurisdictions. So let's talk about some of these areas here. So, here's a list over the next 2 slides here. They're somewhat in a order of priority and ease of implementation, some combination of those. And the first is really just about leading by example. You have your own buildings, you'll have not only demand flexibility operating within your buildings, but also the ability to actually assess those. And provide technical assistance, to building owners and operators, whether public or private. And then when you have this information from your buildings, disseminate that information. Use that to show not only how to do assessments, but also how is demand flexibility, operating. Hopefully it's a positive report, and that encourages more demand flexibility. Second area here, adopting, at least encouraging, if not actually adopting best practices for assessments. And that might be standardized protocols for demand flexibility assessments in your jurisdictions, but also what comes from that and within your own buildings or within your own programs, trying to see consistency in how the DERs, the demand flexibility is valued. And that's part of the assessment process. The assessment process supports that, for your benefit cost analyses, so that you have consistent assessment data that's coming forward that you can use for that benefit cost analysis. Third area on this slide here, supporting advancements in the practices. So this can be pilot programs for public buildings to not only, again, test the options, but also the assessment approaches, leading by example, but also taking it a step further by seeing if you can actually further advance by, taking on some risks, taking on some pilots to assess out new options. And then using that to further, advances. So, the first one is, that list on the slides more about, using existing practices. This last bullet more about taking it to the next step. Another area that's really critical that we find is having access to data. And, this is information from the billing meters that's either found or not found through advanced metering infrastructures, but, adopting within your jurisdictions data access provisions and agreements and regulations, all with, of course, respect for cybersecurity, privacy, and consideration of the interoperability, that is the ability of different systems to be able to communicate with each other. And in the case of demand flexibility, the importance of being able to communicate, straight from, the building to the grid, and perhaps even individual pieces of equipment or systems within the building to the grid, so that the operators can see that, but also have information for diagnostics for improvement. Looking at, following up on that is encouraging your own infrastructure improvements, encouraging demand flexible ready equipment through codes and standards. Many states have their own individual, appliance standards and equipment. Some of those looking at those making, new equipment that goes in, being demand flexibility ready, having the communication systems, for example, and including that in standards. And then lastly here is governments can play a really helpful and critical, if not critical, role in really coordination across programs and markets. You have the resources to encourage, if not mandate, coordination among the utilities and the other market actors to actually see results. And then, support providing of the market assessments that can inform the development of those. So with that, that is the presentation. I've got a summary slide here. I've been going through most of this, so I think I'll maybe just, with 20 minutes left, leave this up on the screen. I'll leave it to you to decide whether that's me or not at an early age doing my first measurement activity, and see what questions we have. Lisa.
Great, thanks so much, Steve. It's not too late to enter your questions in the Q&A box, and we'll try to get to those. Meantime, let's get to some that we've already gotten in the door. So, Steve, toward the end there, you did start talking about some policies with respect to, ways to advance demand flexibility assessments. But the specific question we got in was to ask if you could talk a little bit more about policies that can provide guidance for assessment of demand flexibility, particularly for multiple buildings, in contrast to, in individual building or performance. So this is really trying to get at what policies or regulations could states promulgate to provide some guidance for multiple buildings?
Well, good question. If you're going to have these buildings, one policy starting point is that you have to have assessments, and if they're actually participating in a tariff, there isn't a necessity through the settlement process for there to be the measurement and verification. So if you are going to look at a tariff-based program, is to have a policy that says, as we do these, we're going to have assessments. That's a critical part of the design that, at a year, 2 years of implementation of the tariff, there will be a assessment, and that assessment will look at not only the overall performance of all those buildings, but also, what type of buildings are performing the best, what subgroups, what types of buildings, what demographics, if you're, looking at different building types or different systems, is a building, residential without air conditioning or with air conditioning that perform the best, what is the persistence, of the impacts. So if you're are going to have programs, one is to ensure that there are actual assessments. So that's one policy, is that those assessments take place. Another policy is that the information systems are in place to do this. Some of that might be working towards AMI if that's not existing. There are options to use building automation systems. They're well more sophisticated than they used to be to use those, even if you don't have AMI. But supporting the infrastructure is another policy, as I mentioned, in terms of having that metering in place, or supporting that various standards. There's standards in place today, around privacy, cybersecurity, interoperability, but they're being furthered. They're being, there's the versions 2.0 and 2.3 and such, staying on top of those and either encouraging or requiring that the most latest standards, for example, for interoperability, be used in place in these buildings that are participating in these programs, so that I keep using the term infrastructure is in place. So, these are a range of the kinds of policies that can support beyond the sort of general categories of ones that I mentioned in terms of, leading by example and making sure that it occurs in your own buildings.
Great. I'm going to switch to sort of the opposite end of things, a more technical question from someone who knows MMB pretty well. So as the number of, as the number of devices and modes increases, deterministic predictions will require large models and a lot of data. So to what extent do you think it's practical to use probabilistic predictions for a population as opposed to deterministic individual components?
Well, that's a heavy question there. I guess I would start with, the amount of data. I need to be a little careful here, but, we deal with so much data now, to me, that's just not a barrier. Of course, this is coming from someone who, started with dial-up modems was the way I collected information, for the performance of buildings. So, we have, the data's there. And I think that, in practice, what we need to do is to have more experience with both of those to compare those results and see how they're comparing under different scenarios with different forms of demand flexibility and different DERs to see, what the difference is. The grid operators, they're looking for prediction, whether that prediction's for 15 minutes or 5 minutes from now or tomorrow or the next day ahead markets. They're running their systems based on what they think is going to happen. So, being able to predict that is really critical in having, these various systems in place. I think we need to work through both of those and see which ones are giving the best results for the best applications. But I don't see, unless I'm missing something, I don't see the quantities of data as a barrier today.
Okay. Going back to sort of programs and policies that governments can put in place, here's a question from someone who is thinking about their local government code and the idea of including demand flexibility as part of that, both for residential and commercial buildings. So, there are already appliances, equipment that use, in the residential setting, internet connection to respond to demand. And on the commercial building side, it's a little trickier. So the question is about, do you envision a sort of automated demand requirement, both hardware and software, for controlling new equipment in new construction, rather than sort of a manual response to events? So how important is this automation, responsiveness as something that might be considered for local codes?
So, this really gets into the, what are the best ways to, actually implement demand flexibility and getting it to scale. And there's certainly an active discussion, in the community about, the role of automation. I would say a majority of people feel that to get to scale, and what I mean is, how to put this, get it beyond the early adopters, to really see a massive impact, it will require automation. And trying to keep that simple and straightforward while also balancing, the ability of individuals to control their own destiny. I don't want to get political here, but, there's certainly, that's always going to be, a challenge in regulation of, for the public good, for something that's cost effective, where is the right line for, requirements versus, incentives and encouragement for, having these capabilities. I think we'd all agree that it's hopefully all of us would agree that it's all public good for us to have smoke detectors, as a requirement. Maybe less so about whether there's a requirement that you participate in the demand flexibility program. And maybe just behind that is a requirement to have the capability to participate. So I think that, we're seeing the cost for this type of capability come way down. And so the incremental cost to have this capability, I suspect, will not be high for manufacturers to put it into their equipment and systems. And then, to require that, I think certainly would be an option certainly for new construction. I think California, is moving towards that direction, if not already there. The question is probably going to be is there an off switch? Does the occupant, does the owner, have the capability with that to opt out? And I think that's always going to be the capability. So I think that does address a lot of the concern that as long as there's an opt-out capability, and then there could be a question of whether there's a requirement to opt in or not. So I'd like to see that. I think automation ultimately will be required to get us to scale, is my opinion. But there should always be the capability of people to opt out. But having that system in place, and I think it's going to take incentives and regulation, the combination that we usually see in market transformation, where we're looking to get something to be common practice or required by codes and standards. And there's a couple ways to get that way. And I think what we're doing now in industry in this country, what is being supportive is really market transformation. to make it standard practice or required by code and standard.
Let's stick with new construction for a moment. The question came up about baselines. When you have new construction, there's not a baseline for that particular building, right? And so how do you use modeled or assumed performance? What are these non-baseline approaches that we talk about in the report?
So, let's talk about for new construction, and we see that in, really the example primarily is energy efficiency, where, there can be a standard performance of a building, which really isn't applicable here. And then the alternative is to do some kind of computer model simulation of how the building would perform in the absence of, this capability. How well that's really going to work, I think probably more in practice, is that we would simply have buildings operating in their normal mode, and it's going to be how that building performed last Tuesday versus this Tuesday with the event occurring. That will determine that. There's an approach that can be used also, that I use the offhand term of on-off. If you have a new building, it's got all kinds of quote unquote fancy systems, and you want to see how it performs with and without those, you turn those systems off for a week and then you turn them on for a week and compare, or a month or an hour and an hour. So there are various techniques that have been used for new construction. It can be applicable in demand flexibility. The broader approach is, if we start seeing so many demand events that you just cannot find a weekday that there wasn't a demand event, we're either going to need to just simply change the way the programs work, which is to have them way more dependent on retail rates, the special programs. But even those, my opinion would be is that you still need to have the support of an infrastructure in place to help people get there and know how to manage that and operate that. So that will still involve some sort of incentive programs. So we need to look then at, what are the other ways in which, we have metrics to determine whether the building's doing what we want it to. And that's why, we've talked about in the report, using load profiles. We want you to match a load profile, and we've come up with that load profile based on what the need is for the grid on a given day. And, you're not judged by how you compared with what you did yesterday. You get judged with how you match up to that load profile. And, maybe we just look at load factors, for the week. Did your peak not exceed more than, 100% of your average? Somewhat the way, we've done a sort of a variation of the ratchet, old-fashioned ratchet rate schedules. So
let me ask a related question to sort of follow up here. This is a really good direct question. For direct measurement, how are grid interactive efficient buildings, the resource valued? Get down to those, what are we talking about when we're talking about metrics, and for direct measurement?
So those are the straightforward ones. And I would compare that with a generator. And in some cases they are a generator. I mean, when you go over to the power plant, you don't ask for a baseline. You just stick a meter on the output of the generator and say, yeah, it generated, a million kilowatt hours in that hour. So for storage, for generation, we can do direct measurements today. There really isn't any baseline issue. And so that certainly simplifies things for that. It's really when we look at a change, and it's the change as compared to what, what would have happened in the absence of that signal, of that, whether it's a signal from an aggregator to shut down load or shift load, or it's this price signal that says, hey, gone really expensive, change your. So it's comparing that with what would have been that change that becomes the complexity that we can't just use direct measurements. And that's been the difficult thing of efficiency evaluation forever. And it's really fits back within the fundamentals of any investment that you're comparing, what occur if you do something different.
So let's move on to some other questions, Steve, because we have like 6 minutes left, and let's see if we can rapid fire get to some of these other ones. First of all, I do want to remind people about the second report in the series covered valuing, how do we value these grid interactive efficient building demand flexibility resources. So that's a report led by Tom Ekman, and that's, you can get the link in the slides also on DOE's website for grid interactive efficient buildings. I want to just talk about something that was in the news. You know, the recent California blackouts, they were partially eased with energy efficiency and demand response. And so how can assessment support demand flexibility as a resource to reduce both the potential and the impacts of blackouts?
Well, thank you. Well, let me start by saying that demand side resources, including efficiency and demand flexibility, can be an important tool for grid operators for avoiding brown or blackouts. And they can be really cost effective and zero carbon impact tools. You know, again, it's as compared to what, you know, we have these difficulties I've been talking about with doing assessment. Some of it's very straightforward. Some of it might be more complex, but it's, you know, as compared to what? What are your options? If your option is a blackout, you know, putting a little extra effort into assessment doesn't seem like that, you know, big a deal. So for these, you know, with respect to the assessments, you know, for these operators and utilities to utilize these resources, they have to have confidence that when they're called upon, they're going to respond. And that's where assessments come in. You know, it's the same issue really with supply side resources or storage. You need to be able to count on them, and you use historic performance to give you that confidence. So that record of demand flexibility as documented by assessments can provide that confidence. So, you know, if they want to count on it, they're going to need to have these, you know, quote unquote resources for rolling blackouts. It's, you know, you need assessments. And, you know, they also can provide near real term. You know, that's, you know, some of the comments I'm making here are like, you know, we can look at this and say, this is really the historic performance. They have performed or they haven't. But they also provide almost near real-time feedback. You know, grid operators can use that infrastructure that's in place to see if the demand side resources are responding as expected in near real time and make adjustments.
And by infrastructure, Steve, you mean what kinds of equipment?
The metering and the interoperability communications. You know, this in some ways gets back to the question about data. I mean, it's a lot of data. And, you know, it's going to be, you know, it's all there down potentially to the equipment level, and how that's performing on building A versus building B. You know, we're talking about larger buildings, of course. And, you know, either through the aggregators, consolidators, you know, that information, you know, is available. And, you know, the operators can see whether these buildings are performing. That assessment infrastructure not only supports assessments, it actually supports the actual demand flexibility itself. It's kind of a twofer. Okay,
let's try to squeeze in maybe 1 or 2 more questions here before the top of the hour. So quickly, you know, we often talk about, you know, projected or deemed savings versus actual verified savings. This is something that, you know, is an important topic for assessments of all kinds. So can you talk about when we're trying to assess performance of demand flexibility in buildings, are we talking about projected or deemed savings, or are we talking about actual verified savings? And, you know, maybe point to some information in the report that gives more information.
So we're really focused on actual documented performance in this report. The deemed or stipulated savings would come from this information. And you hopefully, whenever you're doing deemed or stipulations, it's an informed decision, and that comes from experience. So you would use a deemed or stipulated value really for estimating performance. Say an aggregator would, you know, use it's really in this case an estimate that says, you know, I need 10,000 homes to get the demand being asked of me based on my experience. But in the end, it's going to be actual performance that determines their compensation. We really haven't seen deemed or stipulation in these programs other than for estimating for planning purposes.
Okay, great. And I want to try to get to one more question, which is a great one. Are you seeing examples of layering grid flexibility benefits into the value stack, you know, along with, you know, avoided energy capacity and so forth? you know, with more integrated energy efficiency and demand response programs, which are really like the precursors of what we're likely to see for grid interactive efficient buildings. So are you seeing that layering of these benefits in the value stack when you look across programs that utilities and perhaps even markets are offering?
You know, others would probably have more informed answer on that. You know, Tom Ekman in the evaluation report that you and him prepared might have more on this. I would say, unfortunately, probably not. It's certainly talked a lot about. And in the new National Standard Practice Manual for DERs, you know, this is definitely talked about, is, you know, putting those together, looking at all your goals and objectives, resilience, reliability, renewables integration. If that's a policy goal, then you need to consider all these benefits. And that includes this benefit demand flexibility when you're putting together your program, so you don't underinvest by not considering a value that exists out there, such as demand flexibility. Otherwise, you're going to be building lots of peaking power plants.
Yeah, thanks, Steve. Well, thanks so much for plugging also one of our other reports in the series on valuation. There's also an introduction for local and state governments. Steve, thanks so much for your continuing work with Berkeley Lab on all of these evaluation, measurement, and verification issues. Thanks to C-Action, U.S. Department of Energy, our co-author, Sean Murphy. And I think with that, we'll wrap it up. We will be posting a recording of this shortly. You'll also be able to get the slides now and the report that was the basis for this. So thanks so much for joining us. Have a nice day. Bye.